So after we take our standard count and record our density standard and moisture standard, we're going to input our proctor for soil, and we're going to find that off the proctor density report or the project engineer or materials and test. You can contact them for that number. We want to input the maximum density and the optimum moisture for our soil. And that's going to vary from job to job, so you'll need to get that correct number entered to get your correct readings. And we just hit the MAPR. We want to select proctor because it's soil, and we'll input that number. You can change it using the arrow keys. Enter will move your cursor over. And once that's entered, we're ready to select our time. We want to select 1 minute. And our depth for soil is going to be 6 inches. And we're ready to go. Now that we've got the gauge ready and prepared for the test, we want to make sure that we've got all the tools we need to perform the test. We'll need a drill rod calibrated in 2-inch increments. It goes from 2 at the bottom, 4, 6, 8, 10, and 12 inches. We'll need that, and our scrape plate. We're going to insert our drill rod into the plate to the depth that we need for 2 inches, 4 inches, 6 inches, 8 inches, and so on. We'll also need a hammer. We recommend using at least a 6-pound sledge. You can saw it off to make it a little easier to work with in the field. Normal regular hammer is going to be a little tough to hammer this into the ground. So this is what we recommend, but you can use whatever you're comfortable with. For guidance on selecting test locations, see SOP 1-1. So after we randomly select our test site, we want to make sure that we have a pretty flat spot for our gauge to sit. We don't want the gauge to rock back and forth. It needs to sit pretty flat while it's testing. So we can check our site, make sure there's no voids. Take our plate, just run it back and forth. Move any loose material out of the way. And then we'll be ready to make our probe. We're ready to make our hole. First we want to take our pry bar for our drill rod. Place that on there first. Then place our drill rod into the hole. And for these lifts, you want to make your hole reasonably close to half of the compacted depth of the lift. So for this we're going to use 6 inches, and we'll hammer that in. And grab this. Pull our probe out. Make sure that we're still over the hole, and we'll just want to trace the outline of the plate. And it just gives us a template for where to place our gauge to put it directly into the hole. Place the gauge over the hole in your pattern that you've drawn. Just like that. We want to pull the trigger and release the source rod down into the hole to 6 inches. Make sure it clicks in place. And we're ready to take our test. So once the source rod's in the hole, just want to press start, and it'll begin its 1-minute test. And we'll stand back at least 5-10 feet away from the gauge. That way we're not exposing ourselves to any more radiation than we have to. And to note, a single test may be conducted at any test location given that the test count is greater than or equal to 60 seconds. So it needs to be at least a minute, not your 15-second test. After our gauge has completed its test, we're ready to record the information on our paperwork. For this, we're going to use the daily report on embankment for this application. We'll record the location, the date of the test, the station, offset, percent moisture, and the field density. So that's going to be your dry density for soil. And over here, this will just be our sample number and the optimum moisture and our proctor that we inputted in the gauge. And of course, we'll fill out our project information at the top, the contractor, type of material, and the date, county, region. And this is going to be form DT0304. As an alternative for soil density, you can use the density worksheet nuclear method. That's going to be form DT0314. It's going to have basically the same information. You'll want to record your probe depth, density standard, density count, moisture, percent moisture, proctor density, and your optimum moisture, and then your percent compaction at the bottom.